National Electrical Code Article 334.12.81 states that Type NM cable, commonly known as Romex, shall not be installed in unfinished attics or roof spaces. It's important to understand the precise wording of this code section and how it applies to various construction scenarios. The key element here is the phrase unfinished attics or roof spaces. The code does not provide a rigid definition for this term, leading to interpretation based on the specific conditions of the installation. In a scenario where an acoustic ceiling is installed below the truss system, but the bottom chord of the truss system remains exposed, the question arises whether the space qualifies as an unfinished attic or roof space under the National Electrical Code. If the attic space is finished with an acoustic ceiling, a reasonable interpretation suggests that the space is not considered unfinished for the purposes of this rule. The acoustic ceiling provides a level of finish that distinguishes it from a typical unfinished attic. Consequently, based on this interpretation, Romex could be permitted above the bottom chord of the truss system in such a case. However, it's essential to consider several factors and potential counter-arguments. Firstly, the intent of the NEC is to ensure electrical safety. The prohibition of Romex in unfinished attics is primarily due to the increased risk of physical damage to the cable in such environments. Unfinished attics are often used for storage or may be subject to alterations that could compromise the integrity of the Romex cable. Secondly, local interpretations of the NEC can vary. While a general interpretation may allow Romex in the described scenario, the local authority having jurisdiction, or OJ, has the final say. It is always advisable to consult with the local electrical inspector or a qualified electrical engineer to obtain a definitive ruling. Thirdly, even if Romex is permitted, proper installation practices must be followed. This includes securing the cable at appropriate intervals, protecting it from physical damage, and ensuring it is not exposed to excessive heat or moisture. Additionally, it is crucial to consider the presence of any insulation. If insulation is installed above the acoustic ceiling, the ampacity of the Romex cable must be adjusted according to NEC Table 310.15. B3a, which addresses adjustment factors for more than 3 current carrying conductors in a raceway or cable, and 310.15. B3c, which addresses adjustment factors for conductors installed in thermal insulation. Furthermore, if the Romex cable passes through any framing members, it must be protected from abrasion by using grommets or other approved methods as per NEC Section 300.4. In addition to these considerations, it is important to evaluate the overall environmental conditions within the attic space. If the attic is prone to excessive moisture or temperature fluctuations, it may be prudent to use a more robust wiring method, such as conduit or armored cable, regardless of whether Romex is technically permitted. Also, consider future accessibility. While the acoustic ceiling may provide a level of finish, it also restricts access to the wiring. If future modifications or repairs are anticipated, it may be beneficial to install the wiring in a manner that allows for easier access, such as using a raceway system. When making a determination about whether to use Romex in this situation, consider these questions. 1. Does the presence of the acoustic ceiling truly create a finished space that reduces the risk of physical damage to the cable? 2. What is the likelihood of future alterations or modifications to the attic space that could impact the wiring? 3. What are the local interpretations of the NEC regarding this type of installation? 4. What are the environmental conditions within the attic space, and are they conducive to the safe use of Romex? 5. Does the installation meet all other applicable NEC requirements, such as proper support, protection from physical damage, and ampacity adjustments? In conclusion, while a reasonable interpretation of the NEC may allow the use of Romex above an acoustic ceiling in the described scenario, it is essential to exercise caution and consider all relevant factors. Consulting with the local authority having jurisdiction and adhering to proper installation practices are crucial to ensure safe and compliant electrical installation. The National Electrical Code is updated regularly, typically every 3 years. Ensure the most current version is consulted for the latest requirements and interpretations. Always prioritize safety and compliance when making electrical installation decisions. Consider a scenario where recessed lighting fixtures are installed in the acoustic ceiling. These fixtures generate heat, which can affect the ampacity of the Romex cable installed above the ceiling. The NEC requires that conductors be deaerated when installed near heat-producing equipment. Therefore, it's important to carefully consider the thermal environment and make appropriate adjustments to the conductor ampacity. Also, consider the type of acoustic ceiling being used. Some acoustic ceilings are more fragile than others and may not provide adequate protection for the Romex cable. If the ceiling is easily damaged, it may be necessary to use a more robust wiring method. It is also important to consider the potential for rodent infestation in the attic space. Rodents can chew on Romex cable, causing damage and creating a fire hazard. If there is a risk of rodent infestation, it may be necessary to use a wiring method that is more resistant to rodent damage, such as metal-clad cable. Consider the long-term maintenance of the electrical system. Romex cable is generally less durable than other wiring methods, such as conduit. If the electrical system is likely to require frequent maintenance, it may be beneficial to use a more durable wiring method. Also, consider the potential for future changes to the building code. Building codes are constantly evolving, and it is possible that the requirements for wiring in attic spaces could change in the future. It is important to stay informed about changes to the building code and to ensure that the electrical system is compliant with the latest requirements. In addition to the considerations mentioned above, it is also important to document the electrical installation thoroughly. This documentation should include a detailed description of the wiring method used, the location of all electrical components, and any special considerations that were taken into account. This documentation will be helpful for future maintenance and repairs, and it can also be used to demonstrate compliance with the building code. Furthermore, it is advisable to take photographs of the electrical installation before the acoustic ceiling is installed. These photographs can provide a visual record of the wiring and can be helpful for troubleshooting any problems that may arise in the future. Remember that the National Electrical Code is a complex and constantly evolving document. It is essential to stay informed about the latest requirements and interpretations to ensure safe and compliant electrical installation. When in doubt, always consult with a qualified electrical contractor or a local electrical inspector. They can provide expert advice and guidance on the specific requirements for the installation. Also, make sure to check with local authorities for any local amendments to the NEC that may be in place. Many jurisdictions adopt the NEC with amendments that are specific to their local conditions. These amendments can affect the requirements for wiring in attic spaces, so it is important to be aware of them. In some cases, local authorities may require the use of a specific wiring method, regardless of whether Romex is technically permitted by the NEC. It's also important to consider the type of occupancy in the building. The requirements for wiring in attic spaces may be different for residential, commercial, and industrial buildings. The NEC contains specific requirements for different types of occupancies, so it is important to be aware of these requirements. For example, in a commercial building, the NEC may require the use of a more robust wiring method in attic spaces due to the increased risk of fire and other hazards. Consider the potential for future expansion of the electrical system. If there is a possibility that the electrical system will need to be expanded in the future, it is important to plan for this expansion when installing the wiring. This may involve using a larger conduit or installing additional junction boxes. It is also important to consider the potential for future changes in technology. Electrical technology is constantly evolving, and it is possible that new wiring methods and technologies will be developed in the future. It is important to stay informed about these developments and to consider how they may impact the electrical system. In some cases, it may be beneficial to use a wiring method that is more adaptable to future changes in technology, such as a modular wiring system. Another important consideration is the quality of the Romex cable. There are different grades of Romex cable available, and it is important to choose a cable that is appropriate for the application. Lower quality Romex cable may be more susceptible to damage and may not meet the requirements of the NEC. Make sure the selected cable is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. The listing mark indicates that the cable has been tested and found to meet the applicable safety standards. When installing Romex cable, it is important to avoid kinking or bending the cable excessively. Kinks and bends can damage the cable and reduce its ampacity. The NEC specifies minimum bending radii for different types of cables. It is also important to avoid pulling the cable too tightly. Over-tightening the cable can damage the insulation and reduce its ampacity. The NEC specifies maximum pulling tensions for different types of cables. When connecting Romex cable to electrical devices, it is important to use the correct type of connectors. The connectors must be listed and labeled for use with Romex cable, and they must be properly installed. Improperly installed connectors can create a fire hazard. After the electrical installation is complete, it is important to test the system to ensure that it is working properly. This testing should be performed by a qualified electrical contractor. The testing should include a continuity test to verify that the wiring is properly connected and an insulation resistance test to verify that the insulation is not damaged. If any problems are found during the testing, they must be corrected before the electrical system is put into service. In addition to the considerations discussed above, it is also important to be aware of the potential for electromagnetic interference, or EMI. EMI can disrupt the operation of electronic devices, and it can also cause problems with the electrical system. If there is a risk of EMI, it may be necessary to use shielded cable or to install filters in the electrical circuits. Shielded cable is designed to block EMI, and filters can reduce the amount of EMI that is present in the electrical system. In some cases, it may be necessary to ground the shielded cable to provide a path for the EMI to flow to ground. Grounding the shielded cable can help to reduce the amount of EMI that is present in the electrical system. It is also important to consider the potential for surge voltage. Surge voltage is a sudden increase in voltage that can damage electrical equipment. Surge voltage can be caused by lightning strikes, power outages, or other events. If there is a risk of surge voltage, it may be necessary to install surge protectors on the electrical circuits. Surge protectors are designed to protect electrical equipment from surge voltage. They work by diverting the surge voltage to ground. It is also important to consider the potential for harmonics. Harmonics are unwanted frequencies that can be present in the electrical system. Harmonics can cause problems with the operation of electrical equipment, and they can also increase the amount of energy that is consumed by the electrical system. If there is a risk of harmonics, it may be necessary to install harmonic filters on the electrical circuits. Harmonic filters are designed to reduce the amount of harmonics that are present in the electrical system. They work by blocking the harmonics from flowing through the electrical circuits. In addition to the considerations discussed above, it is also important to be aware of the potential for voltage drop. Voltage drop is a decrease in voltage that occurs as electricity flows through a wire. Voltage drop can cause problems with the operation of electrical equipment, and it can also reduce the efficiency of the electrical system. If there is a risk of voltage drop, it may be necessary to use larger wires or to install voltage regulators in the electrical circuits. Larger wires have less resistance, which reduces the amount of voltage drop that occurs. Voltage regulators are designed to maintain a constant voltage level, even when there is a voltage drop in the electrical system. It is also important to consider the potential for corrosion. Corrosion is the deterioration of a metal due to a chemical reaction with its environment. Corrosion can damage electrical equipment, and it can also create a fire hazard. If there is a risk of corrosion, it may be necessary to use corrosion-resistant materials or to install corrosion protection systems. Corrosion-resistant materials are designed to resist corrosion, and corrosion protection systems are designed to prevent corrosion from occurring. In addition to the considerations discussed above, it is also important to be aware of the potential for fire. Fire is a serious hazard that can cause significant damage and injury. It is important to take steps to prevent fires from occurring in the electrical system. Some of the steps that can be taken to prevent fires include using fire-resistant materials, installing smoke detectors, and having a fire extinguisher readily available. Fire-resistant materials are designed to resist fire, and smoke detectors are designed to detect smoke and alert people to the presence of a fire. A fire extinguisher can be used to put out a small fire before it spreads. In addition to the considerations discussed above, it is also important to be aware of the potential for electrical shock. Electrical shock is a serious hazard that can cause injury or death. It is important to take steps to prevent electrical shock from occurring. Some of the steps that can be taken to prevent electrical shock include using insulated tools, wearing rubber gloves, and avoiding contact with water when working with electricity. Insulated tools are designed to prevent electricity from flowing through the tool and into the user. Rubber gloves are designed to prevent electricity from flowing through the user's hands. Avoiding contact with water when working with electricity can help to prevent electrical shock. It is also important to energize the electrical circuit before working on it. Energizing the electrical circuit means turning off the power to the circuit. This can be done by turning off the circuit breaker or removing the fuse. It is also important to test the circuit to make sure that it is energized before working on it. This can be done by using a voltage tester. A voltage tester is a device that can be used to detect the presence of voltage in an electrical circuit. If the voltage tester indicates that there is no voltage present, then it is safe to work on the circuit. However, it is always important to be careful when working with electricity, even if the circuit is de-energized. There is always a risk of electrical shock, so it is important to take precautions to protect yourself. Always remember to consult with a qualified electrical professional for any electrical work.